The thyroid gland is shaped like a butterfly with two wings opposite sides of the windpipe. It's right down here, right underneath your, if you're a male, right underneath your voice box. It produces thyroxine, which regulates the body's growth and metabolism. You've got about 100 days worth of thyroxine in your system. So if your thyroid goes bad, you won't know it for 100 days before things start heading south. Strangely, within your thyroid, you have these structures known as parathyroid glands, and as you can see, they're just little dots on your thyroid gland. Parathyroid is important in calcium metabolism. It regulates your calcium level. Calcium is really important. It grows your bones, but it also regulates your muscles and your nervous system. So without calcium, your muscles don't work, your nerves don't work very well, and your bones get porous, and you certainly don't want that. Overactive parathyroid glands can maintain too much calcium in the blood, leading to kidney stones. This can happen to females as well as males, but it most often happens to males. And we're not exactly sure why. For the longest time, we thought that estrogen protected women from kidney stones, but we do see women with kidney stones from time to time. Doesn't happen very often. Happens a lot to men, but we do see it in women as well. An underactive parathyroid can cause osteoporosis in later life and problems focusing and depression in youth. So if your parathyroid gland isn't working and you don't have enough calcium in your system, now we've got a new interesting problem, especially if you're a little kid. And this is one of the things that they need to look at. This reflects ADHD. It looks like ADHD. It mimics ADHD. They have a problem focusing, and of course, it causes them to be depressed. So if we see a child that is depressed, looks like they need to be diagnosed with ADHD, of course, they maybe have a underactive parathyroid gland, which means we need to look at that. That's another thing that you need to look at when you're looking for ADHD.
So they can be misdiagnosed?
It happens all the time. One of the reason it happens all the time is because doctors, a mother will bring a child in and say, I can't get him to do anything. He just doesn't pay any attention to me. I think he's got ADHD. The teacher says, we do math and he doesn't even get his math book out. That kind of stuff takes place. So the doctor goes, okay, sounds like ADHD to me. And so he diagnoses him. And so he starts treating him with Ritalin. And of course, Ritalin's not going to touch this stuff. If the kid's really has an underactive parathyroid gland, Ritalin's not going to do anything to him. It's not going to work at all. So, and of course, he says, so bring him back in a couple of months, we'll talk about it. And so you bring him back in a couple of months, and you say, well, it's not really doing him very much good. So what does he do? He ups the dosage of Ritalin instead of checking him for an underactive parathyroid gland.
With ADHD, do they get depressed as well? Or?
No, they don't.
So that would be the different factor.
What's a depressed child? Exactly. And that's a problem as well. I mean, we don't notice these things. A lot of times we're in denial as to whether something's happening or not. So, that's a problem as well, especially the depression. How many parents miss somebody that's suicidal? Parents are just in denial that this could potentially happen to their child. They don't see the depression. They don't recognize the depression. They don't want to see the depression. So yeah, this is a problem. This can potentially be a problem. So this is another instance where the problem looks like ADHD, but it's not. It's an underactive parathyroid gland. And all we have to do is give them a synthetic drug, and it takes care of the whole problem. Their ADHD goes away, their lack of focus goes away, and their depression goes away. It's a miracle. It's a Christmas miracle. Or it could be. The pancreas regulates sugar in the bloodstream by producing insulin to convert sugar into the diet, from the diet into energy. The pancreas also produces glucagon to increase the amount of sugar in the bloodstream. So we've got glucagon and insulin. Insulin allows the body to regulate the sugar, and the glucagon, of course, increases the amount of sugar in the system. This is what we need to maintain ourselves, to have energy. We need the pancreas to pump out both insulin so that we can convert the sugar in our system and to produce the glucagon. This is actually this is a healthy heart before they implanted it in someone. I don't want you to get too excited about it. It's a healthy heart. And we were about to implant that one and take another one out. Or actually, we had just taken the other one out. Not us. I didn't have anything to do with this. It's a picture of a healthy heart. That's what a healthy heart looks like. It's about the size of your fist, as you can plainly see. It weighs about 11 ounces. It pumps about 5 quarts of blood a minute through the circulatory system. Pump, depending on how what your heart rate is. Let's see what my heart rate is. It's nothing. I don't have any heart rate. Oh my God. Anybody know CPR? Nope, no heart rate. It beats 2.5 billion times in a lifetime. That's the average for an individual, depending on how long they live, of course. I just told you that I have a friend that had a heart attack last couple of weeks. No, it was last week. It was last week. He's not out of the woods. He's on dialysis right now. He's on a ventilator. Things aren't looking that good, but they asked him to wiggle his fingers, and he gave them a thumbs up. And they asked him to wiggle his toes, and he lifted his leg. So he's not dead yet. There we go. That's all I can say about my friend. The heart is a major transportation system delivering nutrients to and pulling waste products out of the body. So that's what the blood does. It feeds the body, and it pulls all the toxins out of your body. Tries to get rid of them. Blood is living tissue. This is what a red cell looks like. It doesn't have a nucleus. It's not supposed to have a nucleus anyway. If it does have a nucleus, we got a problem because it doesn't function properly. But this is what blood looks like. Once it is allowed to circulate, it has about 200 days of viability. After 200 days, the hemoglobin degenerates to the point that it's non-functional, and the body actually cleans it out. One of the structures in the body that actually cleans the red cells out is your spleen. Well, what happens if you don't have a spleen? Like I don't have a spleen. Does that mean I get clogged up with all these old blood cells? No, it's taken out through your liver and your kidneys, so I'm okay. Don't worry about it, I'm okay. I know you guys were worried about me. These are red cells. These are red blood cells. Erythrocytes is another name for red blood cells. It means red cell. Erythrocyte, erythro means red, cyte means cell. It's used for the transportation of oxygen and other nutrients, and it also pulls waste products out of the system. It delivers oxygen, and it pulls the carbon dioxide out. So that's the job of the red blood cell. Okay. It's the transporting is accomplished by iron. The iron in the blood, and the iron in the blood is known as hemoglobin. Hemoglobin is really kind of interesting. We have throughout our lives, we usually have about 2 different types. One type of hemoglobin is the hemoglobin we have when we're in the womb. Once we are born, then our body has to get rid of all the old hemoglobin and produce adult hemoglobin. And that's one of the processes that has to take place right after a baby is born. And this is one of the reasons why if it tries to break down the fetal hemoglobin too rapidly, the baby will get jaundice. And that's what jaundice is. That's why they turn yellow. As it's breaking down too much of the hemoglobin, the baby turns yellow because of the hemoglobin. The second type of cell in the blood are white blood cells, or leukocytes. Leukocytes, leuko means white. Cytes means cell, white cells. Leukocytes are part of the immune system and patrol throughout the body looking for problems. This is one of the things I did when I was when I was a laboratory technician. I did what they refer to as differentials on a CBC. Differentials, you look at 100 blood cells, 100 white cells, and you identify them by what type of cell they are. Normally, the most abundant cell is the neutrophil. The neutrophil circulates throughout your system in order to kill bacteria, to combat bacteria. The second most abundant cell is the lymphocyte. That's this cell right here. It's looking for viruses. Now, if we look at the European incursion into the Americas, one of the things that happened to the indigenous peoples in the Americas, hundreds of millions of people here, one of the things that happened is that there were a lot of diseases that killed off a lot of people. And one of the reasons it killed off a lot of people was because the immune system, the indigenous immune system was not as strong as European immune system. And the reason it wasn't as strong is because you had never come in contact with any of these viruses. Of course, these are individuals that lived with their pigs. And since they lived with their pigs and since they were trading diseases back and forth with their swine, they developed things like smallpox, chickenpox, measles, mumps. All of these diseases are all viral diseases. And when they brought them to the Americas and infected the people here, you had no immune system against this, and it just wiped people out. Measles wiped out whole villages. Smallpox certainly wiped out whole villages. Anyway, so virus is extremely important. As I said before, over the last couple of years, 3 or 4 years, we had the Zika virus outbreak, and of course nobody had any immunity against the Zika virus, so there was really not a whole lot we could do. We were deathly afraid that a new virus is going to rear its ugly head and start wiping people out again, which would be just a tragedy if you think about it, because we have no immunity against it. Of course, we do have lymphocytes, but none of us have ever come in contact with Zika. None of us have ever come in contact with Ebola. So these things you never know what's going to happen next. Whether a virus is going to, some strange monkey virus is going to come out of Africa, or some disease, Zika came out of Africa. So really strange, really interesting. Anyway, maybe that'll be the death of humanity. Some new virus that comes out. Eosinophils. This is an eosinophil. Eosin is actually a stain, and it's named after the stain that colors the cell. Eosin stain is orange, and as you can see, this is orange to red. Eosinophil. It looks for allergens and parasites. So if you had, back in the old days, everybody had pinworms. When I say old days, I'm talking about when I was a child. Everybody had pinworms. Just about everybody had pinworms. So if we drew blood on people, one of the things we would see an increase of eosinophils because of the parasites. When it becomes spring or fall, we have a lot of allergens in the air, and at that time, of course, you'll have an increase of eosinophils. Basophils are really kind of interesting. This is the darker stain is picked up, and that's a base stain, and therefore they're referred to as basophils. They're looking for toxins and heavy metals. They're wandering throughout the body and capturing these any way that they possibly can. The last type of cell is a monocyte. Monocytes are they're phagocytes. These guys are looking for cancers, and if they find it, they will engulf it. This is really kind of interesting. If the immune system will tag the cancer and will tell the body to attack the cancer. And of course, one of the cells that does this is the monocyte. And the monocyte is phagocytic. So if you have a cancer growing in your system, and we all have cancers growing constantly. We all have mutated cells growing all the time, but our body normally takes care of these with the monocyte. And of course, if you have a benign tumor, that's exactly what a benign tumor is. It has been arrested by your immune system. The monocytes have made it non-virulent, and you have arrested it. You have captured it, and it won't be able to leave. One of the problems we have with cancers, especially if you're immunocompromised, a lot of times what will happen with a cancer is that it will metastasize, so it'll move from one place to the other. And once it moves from one place to the other, the only way it can move is to hide itself in from your immune system. And the way that it does that, it acts as if it is it starts pumping out a substance known as human chorionic gonadotropin. And human chorionic gonadotropin is what protects a fetus's cells. Fetus's cells, despite the fact that they're half the mother's cells, the other half are the father's cells, of course, it's an alien structure. It's not, if it were the mother's system, if it was purely her cells, then there wouldn't be any question as to whether the immune system would attack it or not. But because it is an alien structure, it has to produce something to protect it. And the thing that it uses to protect it is human chorionic gonadotropin. So now we know that cancers, the only way that they can metastasize, if they try to move from one place to the other, normally the immune system will knock them out unless they are producing human chorionic gonadotropin. And that's what a metastasized cancer is. So when we talk about an individual that has a fast-acting or fast-moving cancer, it's usually one that is producing the human chorionic gonadotropin very rapidly. Normally, it'll stay in one place, and the body will try to control it. And then, if they become immunocompromised through a lot of stress, then the immune system will break down and allow the cancer to grow. It'll allow the cancer to leave. And at that stage, of course, now they're producing human chorionic gonadotropin in order to leave. Now we got a problem. And this is one of the reasons why cancers are so difficult to knock out. If you have a cancer where it started, of course, the immune system is working on it, it's trying to kill it. If we find it, then we can always knock it out. We can do something to knock it out, or do surgery and just chop the sucker out of there. But if it is if it already has metastasized, now we got a problem. Because now we're going to have to eradicate it, because your immune system has a very difficult time recognizing it as a cancer. So a lot of times you'll see, in the old days we used to see a lot of lung cancer that would metastasize to the brain or whatever. No. I was thinking John McCain had his cancer started someplace else, but his is a glioblastoma, so it started in the brain and it's staying in the brain, but we don't know what's going on. The third type of cell in the blood are platelets. So we have red cells, we have white cells, and the platelets, these are the platelets. As you can see, they're tiny little chunks of cytoplasmic remnants is actually what they are. They circulate in the blood to form clots when there is a break in the circulatory system from a wound. So we have platelets, and of course you need platelets in order to clot, to form a blood clot. And of course if there is a break, then it needs to form a blood clot. And that's what a platelet looks like. When the heart beats, it is moving blood throughout the system by opening and closing chambers of the heart. Unoxygenated blood moves into the right atrium through the superior and inferior vena cava. The right atrium contracts, pumping the blood into the right ventricle. Okay. The right ventricle pumps the unoxygenated blood to the lungs through the pulmonary arteries, where it picks up oxygen, returns it to the left atrium through the pulmonary veins. I know this gets really interesting. Usually only arteries carry oxygenated blood and veins carry unoxygenated blood. But here we have the reverse happening. So it's a pulmonary vein that is bringing oxygenated blood from the lungs. The left atrium drops the blood into the left ventricle, and the left ventricle pumps the oxygenated blood throughout the body through the aorta. Of course, the aorta is the largest. It's actually larger than the pulmonary artery. Where was I? Oh, I was up in Montana, and there was a Navy SEAL, and of course SEALs are trained not to fight. Okay, they're trained to kill people, and they're trained not to fight, because if they fight, then they might kill somebody. Okay. So they're trained to control themselves. Anyway, this guy was at a dance or something, and of course all the women were hitting on him. You know how women are. Just kidding. All the women were hitting on him, and it made somebody jealous. And this is so weird. It was his son and his father, and it was the son that was jealous. So the father decided he was going to retaliate. Of course, this guy, you know, everybody's not messing with him because he's a SEAL and he can kill you. So they, after the dance was over with, they came up and one walked on one side of him and the other walked on the other side, and the father had a ring knife, just a ring knife, you know, one of those. And he just hit him in the chest a couple times, bam, bam. And the guy didn't even realize what was going on. It's really sharp. It's like a razor blade. Popped him a couple times. Nicked his aorta. They didn't know. Actually, it was relatively controlled. And then when they got into the emergency room, they saw a seepage coming out of his aorta, and they realized that they needed to go in and fix it. And as soon as they opened him up, it burst, and he died. Really kind of a tragedy. But it was the father that stabbed him. It wasn't the guy that was jealous. The father was mad because, I don't know, because the son was upset, I guess. I don't know. It's really kind of a silly story. But the guy died. The sad part was he just graduated from SEAL school. So it's kind of a tragedy. It was a real tragedy. But it was kind of stupid at the same time. Anyway, okay. Systolic blood pressure. So the aorta has a lot of pressure going through it, and that's what happened. As soon as they opened it up, it was being controlled by the muscles in the area, it was being controlled by the tissue in the area, and as soon as they tried to fix it, they opened it up, it just tore. And there was nothing they could do about it, unfortunately. And he bled to death. Systolic blood pressure is the first larger number when reporting your blood pressure. So if I took my blood pressure right now, it would probably be in the 150 to 160 range. Well, the 150, 160 is my systolic blood pressure. This pressure value represents when the blood leaves the left ventricle and is forcing blood throughout the body. It is the strongest pressure that your body is feeling. So your systolic blood pressure is a relatively high number, and always it has to be higher than the diastolic, because the diastolic is the weakest pressure that your circulatory system is feeling. So when we give somebody's blood pressure, what we're doing is we're listening for the high number, and we're trying to find the high number, and we're trying to find the lowest number of their blood pressure. Diastolic blood pressure is the lower, smaller number when reporting your blood pressure. This pressure represents when the circulatory system is the most relaxed, when the blood is moving into the right atrium. So when you're taking a blood pressure, as soon as you can hear the blood pressure, you put the blood pressure cuff on, as soon as you can hear the blood pressure, that's the strongest pressure, that's the systolic blood pressure. And then you listen for it until you can't hear it anymore. So just the last sound that you hear is the low number on the blood pressure, your diastolic blood pressure. As interesting as that is. So it shows you how strong it is and how weak it is. The weakness, of course, it doesn't really mean weak, it just means the lowest number. It's just when you can notice the blood pressure. And mine's high. I have high blood pressure. Talked to Dr. Robinson about blood pressure. I was having a conversation with him the other day. Evidently, they keep changing. When I first started in medicine, I think a high blood pressure was anything over 150, and then they changed it to 140, and then they changed it to 130. I think it's now down to 120 now or something odd. I know, it's really kind of odd. If somebody came into the emergency room with a 120 over 70, we would probably have given them something to strengthen their blood pressure. But now, of course, that's normal, and anything over that is considered borderline. But we have a lot of heart attacks out there. The major part of the respiratory system is the two massive lungs sitting behind your rib cage. Other parts of the respiratory system include your pharynx, of course. It's right here. Your trachea, your diaphragm, your bronchus, your alveoli, and your bronchioles. Those are all parts of the respiratory system. Air enters the body through the nose or the mouth. The skin does breathe, actually. And you can cause a lot of problems for somebody if you block their skin from breathing. In the old days, they used to paint people with really interesting oily paint, and it would cause a lot of problems as far as the breathing was concerned. Well, if they left it on too long, then it would cause the skin to start dying, and this is a really serious problem. Anyway, so we've got your skin breathing and also your lungs breathing. Air passes through the pharynx, back of the throat, and into the lungs through the trachea. Of course, you have a trachea, and you also have an esophagus. The esophagus is where the food goes down into your digestive system. The trachea is the part that collects the air. Is it too hot in here? I was thinking it was too hot. Thanks, Johnny. You're a pal. Or not. Or a troublemaker, one of the two. I can't decide. How hot was it?
79.
Oh, jeez. Who would turn it up to 79? Okay, so the air's passing through your trachea. Then it passes into your smaller structures, down into your bronchi, the bronchioles, and the alveoli. And in the alveoli, of course, is where the oxygen is brought in and the carbon dioxide is taken out. In the alveoli, oxygen from the air passes out. That's what I just said. Okay. So the oxygen is going into your bloodstream through the alveoli, and the carbon dioxide is being released from the bloodstream into the air of the lungs. So when you breathe out, actually you're breathing out some oxygen, of course, but you're breathing out a lot of carbon dioxide. Hopefully you're breathing out carbon dioxide. The process is reversed, and the carbon dioxide is expelled from the body through the mouth and the nose, of course. So when you take in air, you're taking in oxygen. When you're expelling air, you're expelling carbon dioxide. It is a buildup of carbon dioxide in the blood that triggers the diaphragm to contract, pulling air into the lungs. And of course, we can hold our breath. People do hold their breath, and they can hold their breath for an extended length of time. But of course, the carbon dioxide is building up in the body, and you get this really strong impulse. If you've ever been underwater for an extended length of time, you get this really strong impulse to suck in some air. Of course, if you're underwater, you're going to be sucking in water, so I wouldn't do it if I were you. The body is also able to clean dust and other foreign matter into in the air through sneezing when the toxins are too overpowering, and coughing when the throat is irritated. One of the things that happens to us when we have a cold or the flu, whichever the case may be, one is caused by rhinovirus and the other is caused by the flu virus. One of the things that happens to us when we sneeze is that we have a buildup of these viruses, and it increases the amount of mucus. One of the interesting things about the human body, one of the great things about the human body is that we produce a lot of mucus. So if we have, let's say we have the flu. We have the flu. It's only going to be infecting potentially 1% of our mucous membrane in our respiratory tract, but that 1%, of course, will cause the rest of the mucous membrane in our respiratory tract to expel mucus. This is one of the great things about the human body. Otherwise, we would potentially we would not be able to get rid of that virus. So that's one of the things that we have to do. We have to get rid of the virus. Despite the fact it's only 1% of our mucous membrane is infected, the rest of the mucous membrane will produce a lot of mucus as well. And this is one of the reasons why you get such a copious amount of mucus when you have a cold or when you have the flu. I mean, it's just, your nose is running constantly. You're constantly having to blow your nose. Normally, if you have a really good infection, the mucus will be tinged. It will not be clear. So if you just have an irritation and you blow your nose, it will probably be relatively clear. The thicker the mucus and the more discolored the mucus is, then the more likely that you have some kind of an infection, like a sinus infection. And this, of course, then it turns green, turns yellow, turns white. You can usually taste it if you're.
That's what I got over the weekend.
You got a sinus infection? How'd it taste?
Not pleasant.
Not pleasant, it's a bacteria, so what you're tasting is, you're actually tasting the white cells, and you're also tasting the bacteria. So if you grow a bacteria on a plate, it has a certain odor to it, and if that bacteria is growing in your sinuses, you get the same odor or flavor or whatever you want to talk about. Okay, but it has an odor, has a flavor, and that flavor is sometimes metallic. Did you get a metallic taste in your mouth?
I would only notice that taste like when I woke up in the morning. So yeah,
Okay,
I would
sure.
say it's
Yeah.
a buildup.
Those of us who smoke, and I don't, of course, but I know, of course, nobody in here smokes. But if you did smoke, one of the things in the morning, first thing in the morning, you'd be coughing up, those tars and nicotines. So it'd almost be like you just took a puff of cigarette, kind of. Except it's old cigarette, okay? It's a really old tobacco. Ugh. Okay, so that's why we sneeze and that's why we cough. It protects us. It gets rid of all the toxins in your system. Have you gotten rid of your sinus infection?
Yeah, it's just like the aftermath of it right now.
Did you take any antibiotics to knock it out, or did you?
No, all they gave me was Sudafed and Mucinex. Yeah.
Okay, that's interesting. Okay.
Yeah.
Huh. Well, evidently they thought your immune system could knock it out. Okay. That's interesting. The entire air passage of the trachea, the nose, and the mouth are covered with tiny hairs called cilia that traps foreign material like dust or germs and expels it from the body by coughing or swallowing the detritus coated in mucus. So if you swallow your mucus, and some people don't like to swallow mucus, it makes them ill, but if you swallow your mucus, of course, the bacteria can't live in your stomach because it's too acidic. It can live in your mucous membrane, but it cannot live in your stomach. So if you swallow the whatever it is that you've taken in, the dust or whatever, it'll just pass out of your body. It'll kill it, and it'll pass out of the body. And this is one of the natural defense mechanisms that we have. If those of us who've experienced some really nasty things, burning whatever, airplane crashes, there's always something burning. It's usually electrical. Hopefully it's not human, but sometimes it's, you never know what's burning out of that airplane. Some of this stuff is really toxic. And of course, if you come in contact with it, then it will irritate your sinuses. Sinuses will irritate the entire mucous membrane of your respiratory system, nasty as that sounds. Asthma is a chronic allergic reaction to allergens in the environment. 90% of childhood cases of asthma are triggered by either animal dander, pollens, dust, indoor mold, or damp conditions in a building. Well, if only 90% of them are from this, what are the other 10%? Okay, those are the non-allergic asthma. Cold air, viral infections, secondhand smoke, and household chemicals. Actually, that's not right. So there's 10% more that we have to deal with. And so does anybody have any idea what the other 10% is? If it's not something inside the house, what in the world is the kid reacting to?
Is it genetic?
No. Doesn't work out that way. Turns out that it's trauma in the family. The kid's reacting to what's going on in the family. So if there's a lot of conflict in the family, a lot of arguing back and forth, whoever is the youngest one will have an allergic reaction. Will develop asthma, as odd as that seems. And the strange thing is, when you take these kids out of that home, their asthma goes away. It's a reaction to the environment. That's strange. Well, it's always a reaction to the environment. Allergic to dogs or cats, allergic to pollens in the air, allergic to dust, allergic to mold, especially the black mold, damp conditions in the buildings, of course, depending on where you live. So in the old days, what they used to do, if somebody had asthma, they would suggest that they move to a desert environment. And so they would move to Phoenix or Tempe Southern California or whatever, in order to get away from the black mold, in order to get away from the damp conditions in the buildings. And that sometimes worked, sometimes it didn't. And an uncle with asthma, he would winter, how do you do that? He'd winter in Phoenix. And he owned part of the Cubs. Or Mesa, I'm sorry, Mesa, that's where the Cubs are. So he owned part of the Cubs, and he would stay here all winter until the Cubs went back up north to Chicago, and then he'd follow the Cubs back to Chicago. He was a Cub fan, big time. An asthma attack occurs when the body overreacts to an allergen by producing mast cells that constrict the airway. The airway becomes inflamed and produces mucus to combat the inflammation. The symptoms of asthma include coughing, wheezing, whistling sound from the lungs, shortness of breath, and shallow breathing. And of course, at that point, you need to open your airway up. And how in the world are you going to do that? Well, there's a couple different things. It all depends on what kind of an allergy you have, what kind of asthma you have. You can either give them vasopressin, which reduces the amount of fluid, or you can give them adrenaline. That will reduce the inflammation as well. You can't trade puffers back and forth. That doesn't usually work unless they have the same prescription, which doesn't happen all that often. Anyway, there's a lot of different reasons for asthma, and we need to get the right one. There you go, the kid's got a puffer going. Asthma is the most common chronic childhood illness. 70% of all boys have it. That's almost 1 out of every 5. 11% of girls have it. That's a little over 1 out of every 10. 18% of children who grow up in poor families have it. I wonder why. Only 13% of richer children have it. 21% of Hispanic and African American children have it. 11% of non-Hispanic white children have it. So as you can see, if you're poor Hispanic or poor African American, you have a 1 in 5 chance of having asthma. If you're a white kid, then you have a 1 in 10 chance of having asthma. Any idea why? What's going on? Why does it have anything to do with money? Money? Really?
Living conditions.
Living conditions, exactly. Living conditions. Negative living conditions. There's the reason right there. There are 5,000 deaths per year to asthma, though most are older adults who suffer from an asthma attack. I had a friend who was a respiratory therapist, and he became a respiratory therapist because his youngest daughter had asthma. And he was there when she had an asthma attack. He saved her life over and over and over again. And one night, it didn't work. Whatever he did didn't work, and she died. He was devastated, as you can imagine. He had changed his life so that he could make sure that his daughter was okay. And the one night, it just didn't work. One theory as to why asthma is on the rise is because children are spending more time inside where they are exposed to household allergens. These are dust mites. This is what dust mites look like. They are actually an animal that floats around on the dust. Animal dander is another problem. Dogs, cats, whatever. Gerbils, I don't know what you've got in your house. And cockroaches are the other problem. Of course, if you have a clean house, then you probably don't have any cockroaches. But if you're poor and live in a poor neighborhood, then potentially you get to trade your cockroaches with your neighbors because they're not as clean as you are. So despite the fact that you're murdering these guys every day and worrying about it, they're coming from next door. My daughter used to live in Florida. She had a house in Florida, and it was a condominium. I never understood these things. Anyways, it was a condominium, and there were 3 houses. And the guy on the end was a slob. I mean, he was bad. And he had rats in his attic. I know. So everybody had rats in their attic, all the way down. And he was like, 100 feet from her, but the rats from his place would come all the way over to her place. And there was nothing they could do to stop the rats from coming over, as horrible as that sounds. Until he left. And then they eradicated the rats in his place, and then my daughter didn't have rats anymore. Now, I don't know how you feel about rats, but I don't like them. I don't like mice, okay? And these are like big mice, all right? Really, really big mice. Ugh. appalled, and you can smell them. That's the worst part. You can smell mice. If you know what mouse urine smells like, you know it as soon as you walk in the room. Basement. We have mice on the second floor. Sarah's office is a mess. Ugh. Well, her old office, she's not in here. How do you eradicate mice? How do you chase mice away? Cats. Cats, the smell of a cat will chase mice away because they're afraid they're going to be eaten. The digestive system is also known as the gastrointestinal system. Because of the necessity to keep all the cells of the body fed, the digestive system is the most complex system in the body. It represents a tube running from your mouth to your anus, and it runs for as much as 30 feet, depending on how tall you are, depending on how tall you are. It doesn't really have anything to do with anything else. We all have the same amount of small intestines. If somebody is accumulating mass in front of them, it's fat. It's not intestines. It's not like they're expanding their intestines and that's why their gut's so big. However, if we look at chimpanzees, who are very similar to humans genetically, their gut is about twice as big. And the reason it is because we have more brain power and they have more intestines. Food starts off in the mouth where it is emulsified through chewing and a mixture of saliva from the salivary glands to begin digestion. And it really all depends on what kind of food you're eating as to what kind of saliva you are producing. You are always trying to break down whatever is in your system. One of the interesting things about saliva, the more starch that you eat, the more potatoes that you eat, the more rice, the more corn, the more amylase that you will produce to break down the starches. If you've ever noticed, if somebody eats potato chips, a lot of times their breath starts to get an odor to it. And the reason you get an odor isn't because of the starch, the reason is because the amylase is breaking it down. One of the reasons that we cook our foods is because it breaks down starches far more readily. So if you have French fries or you have potato chips, which are very thin slices of potato, it's very easy to start the decomposition portion. And that's one of the reasons why if somebody eats a lot of potato chips, it kind of gives them a little, kind of an interesting flavor or odor to their mouths. Anyway, it gives them bad breath, halitosis to some extent. And it's because of the starch. If you stay away from potato chips, you stay away from starches, then your breath isn't nearly as bad. Okay. But if you eat a lot of potato chips, wow, you got a problem. I used to work for a pathologist that would eat donuts for breakfast every morning. You wouldn't think of donuts. I mean, it's a yeasty smell, right? But boy, I'll tell you what, about 2 hours after he ate those donuts, wow, you couldn't get within. Doing an autopsy with that guy was, oh man, it was bad. It was horrible. You'd have to stay on the other side of the table. It was that bad. And of course, he had no clue. I mean, completely clueless. Talk about a dumb doctor. When food from the mouth is swallowed, it passes through the muscular tube called the esophagus. Food rarely gets stuck in the esophagus because of the power of the muscle and an involuntary reflexive action, a motion downward called peristalsis. So you can hang upside down and you can eat and swallow food into your stomach, despite the fact that the food is going up instead of down. It has something to do with gravity. It's a lot easier to swallow when you're standing up, but you're certainly able to swallow hanging upside down. And you know these ladies are upside down because their hair is hanging down. But they can eat, and actually she's eating. Anyway. As exciting as all that is. In the stomach, the food is mixed with the stomach juices that break down all the complex structures. This is a way that the human body protects itself. You take in a lot of strange things. Potentially you take in a lot of strange things. And potentially you take in poisons. And the stomach juices will break down those toxins. They'll break down the poisons. Hydrochloric acid and pepsin team up to break down complex proteins. Gastric juices can be triggered by the sight or the smell of food, and is one of the reasons for rumbling in the stomach when you encounter food. So all you have to do is smell it, and your stomach starts rumbling. What's going on? You're starting to produce more and more of these stomach juices, and even if you don't eat anything, your stomach is still going to rumble. And that's one of the things that happens. So all you have to do is come in contact with food, and your stomach starts to think about digesting the food. So as exciting as all that is. The human stomach holds from 2 to 4 liters of food at a time. Normally, if you don't expand your stomach, if you don't eat a lot of food when you sit down to eat, you'll only take in about 2 liters of food, which isn't very much. That's maybe a hamburger and a half a glass of Coke. But 2 to 4 liters is, the volume of it is about a burger, fries, and a soft drink. Of course, the soft drink is not 12 ounces, but 18 ounces. Okay, and a bunch of French fries. French fries, of course, are a starch, so they're hard to break down. The hamburger in the hamburger is protein. The cheese is protein as well, so it's going to take a little bit more time to break down that food. The Coke, on the other hand, is going to go into your stomach. It's going to pass through relatively quickly. And this is one of the reasons why you can drink something right now and 15 minutes later you feel like you need to urinate, because it's actually gotten into the small intestines, it's been absorbed into your system, and now the kidneys are flushing it out, and so you can urinate, which is a good thing, because once upon a time when I was in the service, my job, since I was so old, one of my jobs was observing people urinate when they collected drug urines, which is not the most fun thing in the world. But the problem is that if somebody comes in and they don't need to pee, then it's really hard to get them to pee unless you can give them water, you can give them whatever. Usually water works, but it takes about 15 minutes for it to get into your system, unfortunately. Or fortunately, I don't know how you look at these things. It was always kind of irritating to me. There's always one guy that can't pee, so I can't leave until this guy can urinate. It's the way it works.
That's what Aaron talked about too.
It's irritating. Women are much better at it than men are. For one thing, you squeeze your bladder when you sit down on the toilet. Men can do that if they want to, but most men won't. I don't know. Air Force personnel, you never know what's going to happen next. The Army guys are the worst. Oh my God, they were so bad. They could never get the cup. I mean, they peed all over them. So it's just ridiculous. It's like they're punishing the janitors for having collected drug urine. Food slowly leaves the stomach. 4 hours after eating, the stomach is completely empty. So if you eat every 2 hours, and of course they tell you to do this if you're diabetic. One way to maintain your diet is to eat every 2 hours, and your stomach's not empty, so you're not eating as much. You're only eating smaller portions. So this is one way of controlling your diet. But if you wait for 4 hours, of course, your stomach is completely empty. The stomach empties into the small intestine, and the small intestine empties into the large intestine. Digestive juices are added to the mixture in the small intestine to further break down the food from your pancreas, your liver, and your gallbladder. And of course, the gallbladder is producing a substance known as cholecystokinin, and it is to break down fat. So if you don't have a gallbladder, then you're not producing cholecystokinin, and it's difficult for you to process fat. All of a sudden, it's hard for you to process fat. So all kinds of interesting things happen to your stool at that point. The intestine is wound around in the bottom of the thorax, but if it were extended, it would be about 20 feet long, with a total surface area of 3,229 square feet. That's an average, of course. That's about the size of a basketball court. So if we took all of our small intestine and cut them all open, I hate to say this, but I've done that before. It's not the most fun thing in the world. You're looking for cancer, of course. You're looking for something in the small intestine. Then it's like the size of, you could spread it out all over the basketball court. Sounds kind of like a horrible thing to do. But you need all that surface to absorb all of the nutrients that you're taking in. Inside the small intestine are tiny projections of mucus called villi, which absorb water and nutrients. And of course, more water is being absorbed as it passes through the small intestines. The small intestine empties into the large intestine, also called the colon. Any water that is still left in the food mass is absorbed in the colon. And they tell you to do this. They tell you to drink water with your meal or drink a liquid with your meal. And of course, that will mix with it, mixes with the food, makes it easier to digest, to break down into your stomach. Eventually, all that fluid will be absorbed. It's an old trick. It's an old desert trick. I don't know if they still use it. I don't know if you still use it, but when I was in the military, they were training us to fight in the desert. And of course, where the hell did we fight? In the jungle. So what are they doing? They're training us to fight in the desert. They told us not to urinate, because if you didn't urinate, you'd reabsorb the fluid in your bladder. And don't ever drink your own urine. That's the last thing you want to do is drink your own urine. But they taught us not to defecate, and they taught us not to urinate, because we would reabsorb the moisture from whatever was inside. That was the idea anyway, and it seemed to work. You could usually function for about 2 days without taking any fluid at all. I don't know what they teach them now. I think they gave everybody camelbacks in Iraq and Afghanistan. Those fluid-filled bags. Mm-hmm. Yeah. Okay, so the water is being absorbed. Any food that cannot be digested is converted into feces by the bacteria in the colon. If you remember from the earlier part of the chapter, we are about 1/4 our own cells, and 3/4 of the cells in our body are bacteria cells. 3/4 of all the cells in our body are other bacteria cells. So each of us, no matter who we are, no matter where we've been, we are the bacteria that we have come in contact with. If you've been to Japan, if you've been to China, if you've been to Korea, or the desert. Here I am in the desert. So when I go home to Indiana, my original home, potentially I've got a lot more bacteria in my system that really isn't really there to take care of what's going on in Indiana. It's really there to take care of what's going on in Japan and Germany and the desert, whatever, as odd as that seems. So we are each our own biome. We are each our own structure. Unless you live in the same house, and even if you do live in the same house, potentially you have different bacteria than the other person living in your house. Wherever you've gone, you pick up bacteria wherever you go. And sometimes you pick up bacteria that doesn't make you feel very good. This is one of the reasons I don't eat in Albuquerque, because every time my wife or I eat in Albuquerque, we get sick. Something's going on. I have no idea. We can eat in Gallup. Gallup's an interesting town. But not in Albuquerque, as strange as that may seem. A problem with the colon can cause problems absorbing the bulk of the water from the feces. And of course, if you have a problem with if you get a spasm in your colon, it'll cause you to have diarrhea. And of course, diarrhea is probably the fastest way to dehydrate. We have, did I tell you the story of the little girl that came? I told you the story about the little girl. Couldn't figure out what her problem was, and she had this horrible diarrhea. It was so bad that she started dying like the first day she was there, because we just couldn't keep fluid in her. And we started the IV one in each arm, and then we started one in each leg, and we were just pumping fluid into this kid, and she's real close, and she's squirting. I mean, her feces looked like urine. It was that bad. It was pretty bad. Eventually we figured out what her problem was, but it took a while. Anyway. Sorry. It took a while, and she almost died. She actually almost died, and I'm the one that found it. Which would make me a hero, except she almost pooped herself to death, which seems like an odd thing, and nobody's talking about it. Anyway. Her problem was that she had they had given her a broad spectrum antibiotic, killed off all the normal flora in her gut. Yeah, killed off all the normal flora in her gut. And so the thing that was causing her diarrhea was something that's always in your gut, but is usually controlled by the normal flora, by the bacteria. Won't let it reproduce. And when all that bacteria was killed, then the yeast just exploded, and it irritated her bowels just amazingly. So eventually, and nobody had ever seen it before. You know how doctors are, they're not real bright. They want to see the same thing over and over and over again. Well, this is what this has caused, so that we can fix it this way. We'll give them this pill because that worked before. Well, nobody had ever seen this before. And I'm the one that found it. I saw it before, I saw it, and I didn't even think about it, because this is normal flora. It's not, doesn't cause a problem. So eventually we figured it out. Since the kid was about to die, we really didn't have a choice. We needed to look outside the box. And of course, some people can't. You tell them this is the right answer, and they will give you that answer every time, even if that right answer is not working. Well, in this case, it didn't work. So we needed somebody some strange person that would look at things differently. Okay, so yeah, and this was a problem, of course. Any bacteria, fungus, parasite, fungi, virus, or foreign microorganism that can cause you any harm is called an antigen. And of course, the problem was that it was a fungi. It was yeast. Yeast is a fungal form. And we had seen it before, but it had never caused any problems before. And since it never caused any problems, then the doctor wasn't even thinking about it until I told him that that was all that was in her stool, were yeast cells. It was the same stuff that causes thrush, Candida albicans. Yeah, and you know how rapidly, I mean, you get thrush because the normal flora in your mouth, something has happened to it. And it just explodes. Yeah, it's really bad. In this case, it exploded, but it was in her colon that it exploded. Anyway. Took me a couple conversations to convince the doctor that this is what the problem was. He'd never seen it before, and he'd never read about it before. So can he treat her? Well, why not? She's about to die. You might as well treat her for the yeast and see what happens. The immune system attempts to protect the body from antigens. Antigens can invade the body through your skin, your digestive tract, through your respiratory tract, or your urinary tract. You can actually get antigens in through your urinary tract. And I'm going to show you some pictures in just a second. One major part of the immune system is the lymphatic system that is networked throughout the body. You have lymph nodes, you have capillaries, lymph ducts, bone. It's in your bone marrow, your spleen, and this is your spleen right here, this little green sucker right there. It's not really green, it's actually red. Your thymus, which is right behind your heart, and your tonsils, of course. That is a collection of lymph nodes, as strange as that may seem. So you've got, not only do you have a circulatory system that circulates your blood, but you also have a lymphatic system that's circulating all these antigens, all these, all the white cells that are, well, they are actually in your circulatory system. But the lymph system is kind of a extra system. It's an extra system that allows the lymph nodes, or allows the lymph cells to be produced en masse. And they're just waiting for some kind of a disease to take place. Now you can tell when you've had a disease because these lymph nodes will swell up. And you've got lymph nodes underneath your armpit, you've got, of course, your tonsils, you've got lymph nodes in your groin area, these right here, that will swell up. You've got a massive lymph node in your small intestine, and of course that will swell and cause all kinds of interesting problems. But that's part of your immune system. We're trying to fight these antigens that are coming throughout your body. The major instrument of the lymph system are lymphocytes, leukocytes called lymphocytes, as I said before. These are lymphocytes. This is what they look like when you do a differential. As you can see, they're not much larger than a regular red cell. All these purple dots are all, those are all platelets, and these are all lymph cells. Lymphocytes. Lymphocytes. We saw what the other white cells look like, the neutrophils, the basophils, the monocytes. Didn't look at all like lymphocytes. Where are you? There you go. Okay. So as you can see, these guys don't look anything like those others, right? Neutrophils, eosinophils, and basophils don't look anything like this guy right here. So they're relatively easy to identify. Unless they're young. Wait a second. Unless they're young, and then they look like this. A lymphocyte that is young looks like that. And they're larger, and so they're a little bit difficult to tell the difference between this cell and that cell. Other than that, we're okay. Normally, when you have an abundance of lymphocytes, it means you've got some kind of a viral infection like mononucleosis. And that's what we see. Normally, we see just tons of these guys, these neutrophils, because the body's, you've got white cells that are wandering throughout your body looking for bacteria to fight. And that's why we have about 55% of all your cells will be neutrophils. Up to 75%, and we've seen that before as well. When I was living in Lubbock, Texas, I was stationed out in Lubbock. One of the interesting things that happened was the kids kept getting diarrhea. We didn't have any clue as to why. We thought, well, maybe it's some parasite that's causing it in the water, parasite in the water. Or maybe the minerals in the water, but we couldn't figure it out. But the kids had a shift to the left, what is referred to as a shift to the left, which means they had an increase of lymphocytes. So it was some kind of a virus, but we never could figure out what was going on. And some of these kids would have, diarrhea for the whole time they were there. In order to get rid of their diarrhea, they had to move someplace else. They had to be stationed someplace else. We were up on the Llano Estacado, and my kids never had it. But I had a guy that I worked with. He had one of his kids had a really strong allergic reaction to the water, just living in Lubbock, Texas. As odd as that seems. Anyway, okay, so what's happening here? Lymphocytes are produced in the bone marrow and increase markedly whenever the individual encounters a viral antigen. Mononucleosis is huge. The flu, of course. Walking pneumonia is caused by a virus. Measles, mumps, chickenpox, those are all viruses as well. We have pretty much eradicated smallpox. We don't see it in the United States at all. We only see it in select third world areas. Or where there is combat taking place. Syria, for example. Somalia, you'll see smallpox. Lymph is a colorless fluid that circulates throughout the lymphatic system, picking up debris in the form of bacteria and viruses. Lymph is filtered through areas of concentration called nodes, where the lymphocytes gather to kill the invaders. And of course, you've got one right under your ear, you've got your tonsils, you've got the lymph nodes underneath your armpit, in your armpit, and in your groin. And so if you have an infection of any kind, whether it's a bacterial infection or a viral infection, a lot of times you'll get swelling in these areas. The nodes can swell and inflame if the infection is too severe, and these, of course, are known as swollen lymph nodes. That's what mumps are. They affect these nodes right here underneath your ear. And they affect your salivary glands. So one of the tests for mumps is to either give somebody a lemon to eat or a pickle, because it makes you're just thinking of lemons or pickles makes your salivary glands work, and your lymph nodes are right there. I know, it's cruel. It's so the kid can't eat a pickle because his lymph nodes are so swollen. The first line of defense for the immune system is the skin. It's a tightly knit, multi-layered cell mass that covers the entire body, and this is your skin. It actually keeps the heat in, as well as protects you from all kinds of interesting infections. Skin is able to keep bacteria or any other invading substance from growing with an oily substance called sebum, which is emitted from your pores. So if you don't bathe for 2 or 3 days, your skin will get oily. We see this in our faces because, I don't know why we see it in our faces, but anyway, we get oily. You can see it in the corner of your nose. You can wash your nose and it'll turn oily in about 3 or 4 hours because this is normally a dry area. Not only does sebum keep the skin moist, but it contains antibacterial properties that prevent growth of bacteria. So only the good bacteria can grow. Okay. 130, 238, 250. Right, thank you. Second line of defense is the coverings of the nose, eyes, mouth, and respiratory tract. It's a tough covering made of epithelial cells and mucus, producing cells called the mucous membrane. You have mucous membrane throughout your system. And the mucous membrane, of course, will protect you from any type of infection. The mucous membrane of the respiratory tract is covered in cilia that catch dust, microbes, and other foreign materials. Enzymes in your tears and saliva also will destroy bacteria. So actually, you can use the tears in your eyes as an antibacterial substance. You can rub it on a sore, and potentially it will kill the bacteria because there are antibacterial properties to your tears, as strange as that may seem. I had a friend that he had a acne problem, and the way he cured his acne problem was to force himself to cry. He would take his tears and he'd rub it on his acne. And it actually worked. It actually worked. And it was really kind of interesting. It's a mess. When a pathogen enters the body and gets past the skin and digestive tract, its covering of proteins alerts the circulatory immune function that an alien structure must be neutralized. Specialized lymphocytes called phagocytes and macrophages flood the area to engulf the alien structure. This is a picture of gonorrhea. Gonorrhea is a bacteria. This is what the bacteria looks like. They're wait a minute, turn extracellular, gram-negative diplococci. Diplococci, so they're kidney bean shaped, and they're always in a 2-cell structure. That's what gonorrhea looks like. Okay, so one of the jobs I had when I was in the service, since military guys have sex with strange people, might potentially be infected with gonorrhea. One of my jobs was identifying this stuff. So I've seen thousands of cases of gonorrhea, unfortunately. And one of the things that you have to see is you have to see it inside the cell and outside the cell. So the human body is trying to protect itself from the bacteria. So we see it on the outside, but we also see it. These are phagocytic cells. These are neutrophils, and they're phagocytic. So they will engulf the bacteria. Once they engulf the bacteria, they kill it. They can't live outside they can't live inside a cell like that, and they will kill it. And so you see it inside and outside the cells. As fascinating as that is. Now you should be happy that it does that. Otherwise, the gonorrhea, you wouldn't be able to control it, get into your bloodstream, and now you're dead. But that doesn't happen because it arrests it in the urinary tract. When a pathogen is introduced into the body through a break in the skin, the cells in the area try to protect themselves by releasing chemicals that isolate the area and try to combat infection. So we're trying to protect ourselves. We cut our arms, we cut something. One of these substances that we produce is histamine. Histamine causes things to inflame. And when it inflames, it increases circulation. And because it increases circulation, the bacteria, which are very fastidious, they want a temperature of 98.6 or somewhere in that general area. When it heats up like that, it kills the bacteria. So histamine actually kills the bacteria with heat. The phagocytes and the macrophages are attracted to the area because of the chemicals, and they attempt to engulf all the pathogens, and that's what's going on here, even though this is a picture of gonorrhea. Sorry. The release of histamine and the arrival of engulfing lymphocytes and the swelling are all part of the inflammatory response. Okay, and that's how we control diseases, through the inflammatory response. Lymphocytes will release chemicals that produce responses from the entire body. Systemic effects, these are known as systemic effects that may include a low-grade fever, just because you've had some kind of an invasion. You may have a low-grade fever. And of course, as a medical person, you're always looking for a low-grade fever. That means that something's going on. There's an infective, inflammatory process taking place, and this is what we need to determine. Now, the other thing is we need to understand what your baseline temperature is, because not everybody's 98.6. I'm like 96.7, I'm sorry, 96.7. So my inflammatory process is totally different than everybody else's. You know, I may be an alien. You guys may be right. Phagocytes and macrophages will engulf any alien structure. The body's immune system has other equal opportunity destroyers. They have a cell called the natural killer cell, which has got to be the coolest name in the whole wide world. These are lymphocytes that attack disease cells, but they'll attack anything. These guys just wander through your body and attack things because they are natural killer cells. They're like crazy 13-year-old kids with a shotgun. I don't know. They have to shoot things, and they will. And the way they do this is they will inject lethal chemicals into the structure. That either destroys the structure or prevents it from replicating. In other words, it destroys its DNA, these natural killer cells. Just fascinating stuff. One of the chemicals that it injects is interferon. You probably don't remember because you weren't part of this. Well, why in the world would you guys have ever worried about AIDS before? But one of the things that we were talking about back in the 80s and 90s, we needed a cure for AIDS. We don't have one for HIV. There isn't one, but we can slow down the process by giving the individual interferon. And the way we figured this out was in the 80s and 90s, we finally realized that there were these natural killer cells. And then we looked at these natural killer cells, and we looked at the chemicals that they were injecting into all these cells, and one of the things that we discovered is interferon. And then we started giving people interferon. And that works. I mean, it really does work for HIV, which is kind of exciting. Okay, so I don't have a spleen, but I never get sick. Now, why in the world would I never get sick? I should get sick like any time anybody's got a cold, I should get sick. I should be a bubble boy. A piece of my immune system is gone. So why don't I get sick? I never get colds, I never get the flu, I never get anything.
When did you get your spleen taken out?
1985. Almost bled to death. They gave me 6 units of blood. Potentially tainted blood, because at that time we couldn't determine if there was any AIDS in the blood. Nobody knows. Everybody's confused. People want me to die. I mean, it's the dumbest thing in the world. I'll go and talk to a doctor and say, "Oh, you should be dead." I hate it when they say that. I'm not dead, and I never get sick. This just isn't fair. So why don't I get sick? Well, one of the reasons may be that you have natural killer cells that are housed in your spleen. Since I have no spleen, it takes time for your immune system to kick in. So your system has to tell the natural killer cells to be released from your spleen so they can run over to someplace and kill something. But I don't have a spleen, so mine are circulating all the time. So that may be one of the reasons why I never get sick. Because I have all these natural killer cells floating throughout my system, and anytime a disease tries to invade my body, the natural killer cells destroy it. That's my theory. Most people without a spleen get sick all the time, and I never get sick. So, I don't know. I may be a different species. It's possible. I've had students that called me a different species before, not in quite those terms. All cells in the human body are made up of proteins. as exciting as that is. All foreign substances that attempt to invade the human body are made up of proteins as well. Each bacteria, virus, fungus, etc. has a protein signature. And it's this protein signature that is identified inside the body. The protein signature is referred to as an antigen. So all these proteins coming into your system, whether it's the smallpox or the flu or whatever it is, whatever this protein structure is, it's an antigen that's coming into your body. It's an antigen, and it's almost, I got 2:48. Is that what you guys have?
Yes.
Okay. So I got 2 minutes. All right. When an antigen is first encountered, the immune system tries to identify it and potentially fight it by producing antibodies to neutralize the antigen. So we produce antibodies. The antigen comes into our system, we attach an antibody to it. And that tells the natural killer cell or whatever to kill it. And the antigen is produced by the T cells. As exciting as that is, these are cells from your thymus. After the first encounter, anytime the antigen tries to invade the body, the antibodies are circulating to neutralize the threat. This is how we become immune to certain diseases. So if you had last year's flu, then potentially you have antibodies against last year's flu, but you have never come in contact with this year's flu. So now you're going to catch this year's flu, which seems to be more virulent, as exciting as that is. But if you've ever had the chicken pox, then you couldn't catch the chicken pox again. Why? Because you had antibodies floating through your system that were destroying or that were identifying the antigen and destroying it. The reason you got the chicken pox is because you'd never come in contact with it before. So you got the chicken pox. Now you've got all this antigen. The antigen is producing antibodies. Now you can't get the chicken pox again. That's the way it works. Why don't we stop right here? We'll pick this up next time. And since there's only 4 of us in here today, there must be a lot of